Hello guys, and welcome to a video that I really didn't want to make, but there were a few requests and few wishes if I make a video about the GL9 scene decomposition. Well, after a certain pressure from you and really many wishes, I have said that alright, I'll do it. So welcome. Here is a video about how to look into a GL9 scene and how to understand what is going on in there and what to do with your projects. So in this video I'm going to show you the basics and actually how to dive into decomposition and understanding of this scene, of this little project, and also I'll try and do my best to show you how to add another object and maybe even from where to find it, how to download it, and how to put it into a scene. So let's start. In the beginning, if you open your GL9 scene, what you're going to do, you're going to see a few H and CPP files. If you have no idea how to start, first you have to find a file that has its own main function where it all starts. You can try to understand it from going through each object alone. I prefer going through the main function and go as the program runs and understand it from that way. So what do we have here? We have the main function. The main function contains its scene window, and as we are used to from many tasks before, there is a loop that is always calling the poll events. So as we have here the scene window, we need to know what is in the scene actually. The scene window is defined here in the GL9 scene, and it has its own container for the scene and then a few functions. We can see here there is a private function to initialize the scene, and then its constructor and a few handles handling functions for calling the key, using the cursor, and also for the mouse button. They're all used in the scene or in the game. If you haven't used it, you will now see what's going on there. And also we have an idle function that is running always. It's called from poll events. As you can see here, the scene window inherits from the PPGSO class window that has its own poll events function that is always called, and there are few other callbacks that are using our defined onKey function or other functions that are being used or commented, and you can use them and try to have fun with them. So what's going on here? We have the poll events, we have the onIdle, and onIdle, as we're used to, takes time, defines the delta time for the animation, and there is just a boolean if the scene window should animate or not, and then it calls the scene update and render. Scene, as you can see, is just is again a class or object for a container of other objects. And in the beginning, what happens, we need to find it. We can see here that in the constructor of the window, it enables a few OpenGL functions, and what is going to happen about the controlling the depth, or the verifying the depth, and also also the culling, and we can see here that it enables the sticky keys. So if you press the key, it will not be, or actually I'm sure what is the one value. We can see that it somehow defines if it should get the keys or the mouse buttons, or what should happen with it, how it should take the input. All right, and where to bind these keys. So after all these settings, the init scene is called, and the init scene, what does it do? As it is called not only here in the constructor, but also in the resetting. First, it clears the scene, deletes all objects. So now we can see that the scene has its own container for the objects, and well, we can dive into the scene, because that's what contains all the objects and where everything is happening. So we are in the scene. Now we are in the scene, but we are only in the scene.h, which is a header file where all the functions are just declared. We don't see their definitions, but we can see that there is an update, render, and intersect. Well, sure. And what we really need for our each object to see it, there is a camera, list of objects, a container, and if you want to move or interact with the scene or objects in the scene, we need to know which key was pressed. Also, we could want to know where the cursor is pointed. We can also use it with what is happening, and how to navigate or use it for the raycasting. And one thing that you haven't used in your previous tasks is light direction. And here's just one. If you wanted another lights, you'll have to define them, well, probably in the scene, because the scene is everywhere, everything is in the scene, and everything is using. But just declaring it here is everything. You need to also send it to the GPU and another program running, that's the shader. So let's take a look at the functions of the scene that are in the CPP. Now we see there is an update. As we are used to the update, it's always calling all the objects, iterating over the objects and calling their update function, and if they should be deleted, it's calling their it's erasing them from the container of objects. Very simple, very obvious if you're using it very often. Then we have the render, because you don't only want to update objects, you also want to render them and show them to the screen. Also, we have here a function intersect. It's self-explainable. Here we have some vector math to compute if the position of an object and the direction of another object could intersect, and actually just a computation of the vector. So find it in math. I'm gonna explain it further. You just see the intersected, which objects it is intersected. So we can see it's most probably, I have a hypothesis that it's used for the clicking in the scene and in the window and selecting objects. So I'm gonna go back to the GL9 scene and look for the function intersect, and we can see it here. So I know I'm a little bit jumping, but I'm going through what is happening if I use the function intersect. it's called in the onMouse button function in the GL9 scene, and it's understandably the handler for the clicking of the mouse. The on-cursor position is handler for the movement of the mouse. In the scene, as I show you, there's a cursor which has its own directions, the positions, which saves the position of the cursor. And in the old mouse button, if the mouse button is pressed, it computes the position of the cursor to the real coordinates in the scene, sets the direction, and casts the ray to the scene, and computes if the vector or the mouse the ray intersects with some object in the scene. So that's for the mouse clicking. You can also use it in your project, even if you're using it for not just pressing asteroids and exploding asteroids, but also for selecting some objects and moving them with the click. As you can see here, even if the mouse is clicked with right or left button, the action is actually it's the same. Well, in this implementation, or actually nothing happens because it's just stored as a right mouse click, and well, for now we don't see if anything is happening with it. So we know that there is something happening with clicking. With on key, with R, we in the scene we reset the scene. With P we pause the scene. So now you can see what is defining the animate. In the on idle is depending on if the game should be paused. All right. So let's dive into the init scene again, as we want to see how the images or the objects are implemented in the scene. So first, there is a camera, again in the unique pointer as its field of view ratio of the scene. You can also set it not just as 1, but by width divided by height. Oh, no, that is like. And what I want to find is that by size you can define the size of your window naturally. Okay, so you know how to do this. You did it many times before, and you set the camera again by move, because you need to use just its object and set it to the camera object, that is also just a unique pointer. So we go back, and now at space background objects, we have defined it as a space. It's calling its own constructor, default constructor, because this doesn't have any parameters. Then we create generator, set it generating and starting a bit upwards, and then we create a player. So as you can see here in the includes, the GL9 scene only uses camera, scene, generator, player, and scene. Other objects are generated and used in different objects as you are implementing them during the tasks. Maybe just the generator. So now let's start with maybe something simple. Let's go into space. Ooh. we see that the space is inheriting from object. You can go to generator, it again inherits from object, and also the player inherits from object. And even if we go to the asteroids, they all inherit from object. So let's start with this object, what it is. As you are used to, is the abstract class as you defined it in your specifications. And most of the other renderable and even non-renderable but function animated objects inherit from the class object. So even when I will be creating my own object and implementing it into the scene, it will be inheriting the object. So yep, we see that it's update, render, and on click, because it can be clicked on. Rotation, scale, and model matrix, so the parameters that we are used to. So as you can see, object has even its own CPP file, and we can see that everything here is just the model matrix that is computed by the standard or the default in the default order of the multiplications. So let's close these because they're not interesting anymore, and let's take a look back to the space. And as you can see here, every object needs its mesh. It needs the pointer to a shader, or the program that is running the shader. It should render our object to the scene and the texture. And you can see here there is even a texture offset. Well, if you ever wondered what it is doing, why it is here, well, if you play the scene, you can see that the texture is actually, that the space is actually moving. And well, it's not moving really, it's only the whole scene is static, and what is really moving is just the texture on the background, and then of course the asteroids moving forward to the rocket. So the illusion of moving and generated scene is only by setting the texture offset. And we can take a look at here, because we can take a look at the shader. Well, how to see it? Well, let's go to the implementation of the function. We can see here that this shader uses a simple texture vertex GLSL and texture fragment GLSL. So it doesn't use the diffuse vertex, because it doesn't need a diffuse lightning. So let's go to diffuse texture, diffuse frag, and take a look here. It defines its shader, defines a texture as it loads stars from the BMP and the quad object. So there is pretty much self-explanatory. It uses the object generate model matrix and returns always true, because it should be always visible. What is interesting here, it doesn't need the depth mask, and it's not writing into the depth, because it's always in the background. It's always the most far away object in the scene. Yep, here's a note. It doesn't use the view matrix. It's defined as it is, as just some square or the quad on the behind of the behind of all of these objects. But it uses texture. Also the projection is again the identity, so it uses model matrix, as is the quad defined as looking at us, and as you can see here, there is a texture offset which is updated here, and the texture offset is set into the texture frag, and you can see here that it's actually using it as a as a value that is used for computation of the fragment color and for the UV mapping. You were really using only this, and texture offset was always 0 because you have never used it in your tasks, but now you can see what is happening in the space. So let's go back to the space, and again we can see that the texture is also moved to the object and computed. So that's about the space. Again, mesh, shader and texture has to be defined, and they are shared and also defined in the CPP file only once. Okay, we have the space. What was next? Alright, there was a generator. Because what's going in the scene, we know that there is a player and there is a generator generating asteroids. Well, maybe the player would be a little more simpler, because there's just a player that is moving around. I think I can close the space and also texture, and maybe not the scene, we'll see about that. Let's go to the player. Again, as you see, mesh, shader, texture, and in the last task I was talking about how you can create the firing rockets or the pouring of the water, and you don't want it to pour every time. You want to compute some the delay and have some kind of a fire rate. So there you have it. You have the fire delay and fire rate that are used in generating the of the rockets, because I forgot that the player is generating also rockets, not just the generator is generating the asteroid. So yeah, you actually did it in your task. So let's go to the update. So as you can see here in update, it's adding the delay. You can see that it's also increased in the scale, and as in the last task you had to create a generator or the generating object. Now you can see that even the player is generating yeah, it would be nice if it was happening here, but it's actually happening here. No, where it is? Ah, here it is. I'm so sorry. So it's here. As you can see, the fire delay and fire rate with pressing the space. Each time the update is called, one rocket is set to the scene, and the fire offset is defining that it's not shot from only from the middle of the rocket ship, but it's fired from the right or the left, as it's defined as 0.7 on the x-axis. So it's moved a little, and it's swapped if it's going to fire from the right or the left side of the rocket. And then also, as you know, it's moved back to the scene of objects from the scene. So the movement of the rocket is defined here. Every time the left key is pressed, the position is moved by its speed 10, and the rotation is also set as it's simulating the tilting, yaw, pitch and tilt. Right now I'm not sure which one is which, but probably yeah, one of these. The simulation of rotating of these of the rocket going to the left or right. And if nothing is pressed, as the scene keyboard map is empty, it should stop being rotated. And yep, here the first one that I was highlighting is not really the movement, but it's actually checking the position of the asteroid, and if the asteroid is near the rocket, so it means it hits the rocket should explode. The player, the spaceship, you know what I mean. Rocket is something different. It's called a projectile. So, well, there are two things in player, and that is the explosion and the projectile. Well, let's go to projectile. As you can see, it's the really similar and as everything. And what I forgot in the player is the render. It gets its light direction, projection, view matrix, model massive, texture. The same thing goes to the projectile. It gets light, projection, view, model, and texture. And also it gets its movement and its texture and the object. Probably if you tried to play a bit around, you found out that the Sea Lion have its own plugin for objects, and you can watch it like this. There you go, some vertices, and here we have shown the rocket. Zoom it. This is how it looks like. Yay, so pretty. Nice. And the missile BMP. It looks like this. It's a mess. You have no idea what does it mean, but believe me, the UV mapping in this missile.obj is somewhere here from B and VT. It should work like a charm, and it should show you these. What do we have here? We have an O, and we can see that the O is defining the name of the object, because every .obj may be created from not only one but from multiple objects in the scene or in the object file. What is going on and why am I talking it? Because I have downloaded my own object. It's a bit larger, and you can see here that it's created from few more objects than just one. And yeah, I tried it without outside of the project. I tried it in GL6 mesh, and I found out that the loader tiny obj can also load objects with multiple objects inside of it. And however, you need them to be with their correct texture. The texture to the drawer is like this. So you see again. Alright, back to the missile, or the projectile. Da-da-dum. Yeah, what I wanted to show you is the light direction. As we go to the diffuse vertex and diffuse fragment, now you can see that there is a direction of the light. By the set uniform, it's set to the light direction that is defined in the scene. So every object has its own, has the same light direction. If you want to create multiple light directions, you have to define multiple vectors for the light, and then of course compute the lightning from all of these light direction from these vectors, and there would be a lot more math and vector computations. Okay. Yeah. Okay. So back to the projectile. I don't think that the further is necessary to explain. It's what you are used to. So I can close the projectile. And what is actually important here, that update has its own scene that is added from the on idle, or actually that is here in the scene CPP, as it calls all the objects and their updates. Also this update is called for the player, and why am I talking about it is because it also gets a scene, and from the scene is always watching for the asteroid, and to check whether the object that is flying around the spaceship is asteroid, there is a dynamic cast that works and doesn't well, if it works, if the asteroid is real asteroid, that it gets the object. If it's not, it gets null pointer. So that's why it's here checked whether it's the asteroid and not. If not, then it's continue and searching for the real asteroid, the object of the asteroid. And as you can see, it's in the scene. Well, now the scene is pretty much easy and pretty much simple, and it really contains all of the objects. If you are certain that your scene will have many more objects, and some of these objects will be somewhere locally stored and they cannot interact with other objects, and there will be a lot of them, maybe some small snow globe, or something like that, that would have or the pouring water from in the sink. You maybe don't need to always check every small ball or the sphere of the water droplet with the table that is on another part of the scene and somewhere completely different. So it's probably the best idea to create more of these containers for objects, depending on whether they can or cannot interact, or maybe define more of them. So it would not always have to go through all of these objects to check if they should interact or not, should not. Okay. Yeah, so another is the explosion. Well, explosion is also interesting because it has its own well, it's deleting by the maximum age, and the age, as you know, by in about 0.2 or 1/5 of the second will disappear. But as far as I know, the explosion is also transparent. So I'm trying to find out where it is. Okay, here it is. So as you can see here, it again calls for a texture. It calls for a texture vertex. It doesn't call for the diffuse vertex. And if we take a look at the diffuse vertex, okay, there is the transparency is defined here, so it's good, but it doesn't actually need the lighting for the explosion. So it only uses the texture vertex. the texture GLSL, because it loads the texture explosion, has its own object, and there is a defined transparency, which is also changed depending on the age. And that's what I said. Go to the texture frag, and we can see that it's different. There is a transparency defined here, and it's defined as the fragment color alpha channel. So the shader makes it a little bit more transparent. Alright, what next? Yeah, sure. We can go to the asteroid, because the no. We are going to the generator. What is interesting here is the object that also inherits from object, but it's not really viewed or rendered, so its render is empty. Its update, on the other hand, is generating the asteroids. So yeah, it's a little bit more easier than the player. Okay, so that is probably most of these objects. So what I am going to try to do, well, we'll see in the next part. And the next part is about trying to implement a new object that should be rendered in the scene. Well, to get there, we first need to download an object, and for that you need to download it from some site. Well, probably you will not see it, but if you want to download the object, just search for the low poly name of the object and .obj. Okay, I'll try to show you that. So I googled low poly table, and here I have a few of them. There's a free 3d.com. It seems interesting, so let's go there. And yep, here we have a few objects. What to look for: the tiny obj can load only .obj files, not .textures, .blend. .blend is a project for the Blender. FBX, well, not sure. And what I did, well, I tried to download several of these objects, and then I downloaded this drawer bedside. It's complicated, it seems fine, it seems nice, it's free, it has its own texture. Well, yeah, so I downloaded it and opened it in the data. So going back to the project. What is also important, if you download your object and just put it in your data, which is fine, you have to run the CMake again, because it will not be copied to the working directory on its own, but the last two lines of the CMake will do that for you. I didn't put it there, I put it directly to the working directory. As you can see, it's the drawer, and it's here, drawer obj, and yeah, now you can see it. It's beautiful. Okay, come on here. Yeah, so it's here. There's also the texture for it. So, well, how to very simply find out if you can load your object in your scene. I'll go to GL6 mesh. What you want to do is to add another line for the texture. Let's say change the cube to your object, And if you want to see the texture, you need to rearrange a few lines of code, because what is happening here, you are setting for the program with its parameters of what should happen next. So now let's see, we have the cube matrix, we have the cube which should be rendered, and first I set its view matrix, its projection matrix, its texture, which is loaded one, sure, its own model matrix, and then I render it. If I want to render and show another object, I have to do all this and again for another object. If I would do that, I want to render them all at once, these set uniforms would change the settings in the shader, so I would see always the same object, or the object with the same settings, which I don't want to do. So that's why first object, then again all of these settings for another object, and yeah, then for something else. If you try it here, you will know if you can load your image, load your object with the texture. Also, as you can see here, my object here, my object also has its materials, but I'm not going to write it here. You know how to set the uniform values to the program. So what you have to do is to define, not here in the vertex, but here in the fragment, what you have to do is to define these parameters of the shown or the used material in your shader, and then compute, it should be better here, and then compute the lighting with these parameters. As you can see here, there is just the diffuse lighting in the material. The KD is the diffuse parameter for this object. So I'm gonna close this because now I don't care about it. Also not this. And what am I going to do? Well, I want to create my own object, and my own object, I would really like it to have its own class, so I'm going to set, let's say, yeah, add new C++ class. Well, let's say it's gonna be drawer, because why the hell not? Add to target. You can see that the C-Lion is very smart, and it see that if you want to add new C++ class, you want to add it into the GL9 scene, or actually into your project, and it does it on its own. It would okay, it's not showing it here, but it would add the drawer into the CMake file. I didn't add it to the GitHub because I don't want to push it. And now you can see it's here in the CMake lists, even if I wasn't pushing it there. So we can close this, but yeah, maybe we have to rerun it again. Good, everything is good. So what to do? Well, let's take a look at something simple as projectile, because it would be just, oh, maybe not projectile, maybe just the asteroid. Yeah, that's nice. We have on click, yeah, maybe we don't want to on click, so maybe again I'll go back to the projectile. Yeah, this things are pretty much simple. I am too lazy to write it on my own. What you can see here, there's pragma once. What you can see here is infdef define. It does actually really the same thing as the pragma ones. Oh, I used also the include. So yeah, I don't care about this, and I don't care about this again. What I want is to define my drawer, and so I will delete these, and yeah, whatever, just call it drawer. Yep, all nice. As you can see, yeah, we don't need the age, maybe we don't need even the speed, maybe rotation momentum. Yeah, that could be nice. We need its own how is it called, constructor, and then also update and other things. So here, what does it say? Generate definition of the drawer. Nice. Let's go to here. Update function. Ooh, we want to do generated. Nice. Oh, it returns false. We don't want to disappear very fast, so return true. Yep, that's it. And again, the render. Come on. And what do we have here? Oh, also destroy. Do we want to destroy? We don't, but okay, we don't want to destroy it. So we don't need it. We just want to show it in a scene with some rotation momentum. So again, let's take a look at the projectile CPP. Okay, this seems nice. Oh, what will we do? Let's go like this, because we need shared resources as it's computing with the shader, but it's not projectile, it's drawer. Yeah. Constructor is having some problems. Oh, not here. Yeah, so maybe just give it some rotation momentum. Now it's defined. Yeah, well, leave it like this, because why not? It should be rotating around the Z. Well, I don't want to rotate it around Z, as it's defined that epsilon is up, so I want to rotate it around epsilon. If everything's correct, it should be like this. Alright, let's go here. Projectile CPP. Okay, we need to also initialize our resource. Oh, it needs diffuse vertex. We don't have it here, so we need to go to includes, and yeah, probably like this, and also we will need to include, come on, yep, we need to include scene.h. It's with a small s, sorry. Alright, it should be here. Now you can see that the shader is here, but we don't want to be the missile, we want to be the drawer. Here is again drawer. So now we have set objects. Ooh, and what about the update? We don't have the speed, but we have the rotation. And again, we don't need its age, but we have its generate model matrix, and we want it to be always there. So we used the generate model matrix from the object that I mentioned at the beginning. Nice. What is here next? We need to render it. So first we need to use the shader to call it from, well, if you don't know what is the shader, you can see here it's defined here, and what it really is, well, as you can find it here. It gets its program ID because it's a program, and the shader is actually a standalone running thread that it's doing all the hard work with computing how to render and view the objects you are trying to model into the scene. So that you can also try to look it in there. So the render, I'm going back here, we get the shader from the scene, we get the light direction, projection matrix, yeah, it should be the same, view matrix, yeah, probably model matrix we have computed, and the texture, sure, nice. Good, we set it here, and the destroy. Well, no, we don't want to destroy it. So yeah, that's it. Nice, we have our own object set. What to do? We have to set it into the scene with its own, within another container of objects. Where it is. Yep. Let's say first we have to include it because it doesn't have any idea what we are talking about. If we want to add something, we called it drawer. Sure, why not with the capital. Okay, I'm not sure how large the object is. It's probably pretty huge, so we will see if it's rendered and where it is rendered, if everything's correct. Okay, so we will create a drawer with std make unique of drawer, and what are the input variables? Yeah, nothing. So that's good. What we need to do, oh, okay, maybe we didn't have to do it like this, just very similar to the space. So we got a scene, objects, pushback, std, move, because let's make it simpler. Like this, std make unique. Yep, that's it. Now we have our drawer in the scene. The scene, when it calls its sorry, when the scene calls its function update, it goes through every object and it should be seen within the objects. I'll try to show you. As you can see, well, you can't see really nothing. It's there, it's somewhere here, but it's behind the space in the behind. Well, why is that? Well, because it's in the stack and it's defined behind the space. So what should we do? So what should we do is that we should send the drawer in front of the space. Let's say it can be even here, and try it again. And now we can see there is a drawer floating in the space. Well, I set it that it should rotate around epsilon. Well, it seems that it's defined differently, so let's repair it. And if we are going to repair it, we can use it with diffuse lighting, or we can change the diffuse lighting into texture, just computing with the texture. we'll see the difference. And also where it is, it's here. It's not here, it's here. Okay, the rotation momentum, well, let's hope I will not make a mistake. I don't know, here, that it should be rotating around its z-axis. And if everything works, now we'll see the pretty drawer in the space. Well, as you can see, it's magnificent. We have the Russian floating night bed drawer floating in the space, pushing, attacking the objects. And plus, if you see, it's rotating only around its z-axis. However, the 0 point, the beginning of the coordinate system is not in the middle of the drawer, so if you want to change something about it, you can open it in Blender and just move it around a little, and it would look much more natural to move. So yeah, there you have it. Oh, and the clicking. Now you can see I'm using my mouse and clicking. I'm clicking into asteroids, and if I click to the spaceship, you don't see it, but it's writing into the console that the player has been clicked. So that's it. Now you see how to implement a new class into the space or into the GL9 scene, or even how to recreate your own scene and to start your own implementation of your own project, or just to decompose this everything and switch it for whatever you want. Also, if you want to change the camera, in the GL9 scene there is also the camera. It's defined with its default position. The camera is defined only as a matrix as it was in the task 7, the projection matrix, view matrix, and the parameters to set it, how it would look. And also here the very useful function cast, of where are we clicking in the scene when we are clicking through the camera, through the window. So yeah, I think that's it. It's quite longer than I expected, but if it helps you, well, it was worth the time. If it won't, well, either way, good luck with your projects. Have fun.